In this video, we'll discuss systems of linear equations. Now, systems of linear equations are a collection of two or more linear equations that share the same values that create true statements. When we do this, we have three options for solutions. One is that the lines intersect at a single point, and we list that point as the solution. Another option is that the lines are parallel to one another, and therefore there can be no solution since there's no intersection. A third option is that they simplify to the same equation, so that only one line would technically be graphed in the coordinate plane. When this happens, we write the word dependent. Now, to solve our system, we use three different methods. We can use graphing, substitution, or elimination. All three will produce the same solution, but we want to use the one that is easiest for us to use and provides a precise solution. Now let's start with graphing. If we're going to do graphing, the first thing I would do is rewrite them into slope-intercept form. This makes it easier to graph both of the lines on the same coordinate plane. Then I'm looking for where is there an intersection between the two lines. Sometimes you may have to zoom in or zoom out from your graph to see that if you're using a calculator or something like Desmos. On a TI calculator, if you want to get the precise location, you can use the calc option, which is in that top row of buttons, and look for the word intersect, and then follow the instructions. Now, graphing will not always provide a precise solution, so it's not always the best method to use if it doesn't produce that precise solution that you can convert over to a fractional form, which is more precise. Let's look at an example. Say I have y equals 2x plus 1 and 3x plus 3y equals 12. Now the first thing I would do is rewrite this second equation so that it is also in slope-intercept form. In this case, I would subtract 3x from both sides. And I'm going to rewrite that. Instead of putting the minus 3x, I'm going to put it first because that's often how we see slope-intercept form. And then I'm going to divide all three terms by 3. This leaves me with y equals negative x plus 4. Now I have two equations in slope-intercept form. I can easily graph them. So I'll start with the first one, 2x plus 1, and then I'll start with the second one, negative x plus 4. And I'll look and say, oh, right there is an intersection. And I can see very easily that that is at 1, 3. So the solution to this system is 1, 3. Now we can use other methods as well. For example, let's look at substitution. With substitution, I'm going to take one of my equations and I'm going to rewrite it for a single variable. Now you can use either equation and any of the variables. Just choose the one that is the easiest to simplify across. I take the expression that that variable is equal to and substitute it into the other equation to solve for the remaining variable. That numerical value can then be plugged back into either equation to find the value of the first variable. Let's look at an example. So say we have 3x plus y equals 5 and 6x minus 2y equals 30, and we decide we want to use substitution. So for me, I would take this first equation, since it's already with a single y, and solve this so that it's y equals. In this case, that would mean subtract 3x from both sides. So now I have y equals negative 3x plus 5. Now what I'm going to do is I'm going to substitute this expression into the second equation for y right here. Now when I do this, I need to pay close attention to distribute that negative 2 to both terms. This will produce 6x plus 6x minus 10 equals 30. And it's important to pay attention to that negative. Now I'm going to just simplify. So I've got 12x minus 10 equals 30. I'm going to add the 10 to both sides. So I'm down to 12x equals 40. And I'm going to simplify that to 40 twelfths, which if I divide all terms, I can simplify it even more to 10 thirds. This is a case where that would be very challenging if I was on the graph. So I want to keep that in that improper fraction or a mixed number if you prefer. Now I take that 10 thirds and I can substitute it into either equation for x. So I decide to use it with the first one. So 3 times 10 thirds plus y equals 5. And that simplifies to 10 plus y equals 5. Now I subtract 10 from both sides, and I get that y equals negative 5. That means the solution was 10/3 negative 5. And if I graph them, I could see that, and here, 10/3 is 3, and you would get the repeating 3's on a calculator, but that's not precise. 10/3 is, or 3 1/3. Now we can finally use elimination. With the elimination method, we first need to make sure that our variables are aligned with one another, so that if it's x and y's, the x's are aligned and the y's are aligned. Then we determine which variable we'd like to eliminate. We eliminate the easiest variable, and we're going to multiply each equation as may be needed so that we can eliminate. Once we've multiplied the equations correctly, we're going to add the two equations together, and this should leave us with one variable, and one variable should add to 0. We can then solve for that remaining variable, and then use that numerical value to find the first variable that we eliminated by substituting it into an original equation. So let's try this out. Now here I have 8x equals y plus 2 and 2x plus 3y equals 20. First thing I'd want to do if I'm using elimination is move the y so that all the variables are aligned. So I subtract y from both sides so that this would be 8x minus y equals 2 and 2x plus 3y equals 20. Now my variables are aligned. Then I want to look at and say, well, what variable to eliminate? I'm going to eliminate y because that's very easy to multiply to get so that they can be eliminated, because what I would have to do here is multiply by 3. So I'm going to multiply my first equation by 3, and what that will produce is 24x minus 3y equals 6. This is the same equation because all terms were multiplied by the same value. Now I can add these two equations together, and you can see negative 3y plus 3y will simplify to 0. So let's do that. I'm going to add the two rows. 24 plus 2 is 26. Negative 3 plus 3 is 0. 6 plus 20 is 26. Now I solve for x by dividing both sides by 26, and I get x equals 1. Now I can use that value and substitute it back into either equation. So I'm just going to substitute into the second equation to show that it'll work. 2 times 1 plus 3y equals 20. I subtract the 2 from both sides then, and that'll give me 3y equals 18, or y equals 6. So my solution is 1, 6. And if I graph these two lines, I would find that they do intersect at the point 1, 6.